Hi, everyone. Super excited to be here in this virtual event. Just I guess there's no chat here, but hopefully many of you will be in the actual event in Toronto next week. So I'll be there myself. So looking forward to maybe catching up and chatting with many of you. Today, I'll be diving into agents. What are they? What are the building blocks? How do you build them? I won't go into multi-agent systems and the more fancy, complex stuff, but my goal really here today is to give you a sense of what are all the components you need, how would you put them together, show you a few code snippets here and there, and hopefully you can start building an understanding of what these things are beyond the hype. Yushi already gave my introduction, so I'm going to skip the slide. But maybe a little tidbit about myself is my background is actually in biology and public health. So I came into this field sort of from left field and don't have a traditional computer science and math background. Just maybe to let folks out there know who aren't in this area that you can get into ML and AI, and a lot of it is applicable to a lot of sciences and even creative disciplines. So with that out of the way, just wanted to level set a little bit with everyone here. The elephant in the room really is that the term agent is overloaded, not just colloquially, right? So the power of this concept in AI is that we have a very clear mental model of what this means in everyday language. So, if you look at the dictionary, an agent is someone who can act in place of another, right? So you can have I guess a travel agent, a federal agent, etc. So this evokes already some level of intelligence, some level of abilities that we're all used to in our everyday lives. But I'd like to unpack these various definitions, right? If you're coming from a traditional or classical ML background and you have some background in reinforcement learning, agent also has another meaning, right? An agent is a thing. This could be any kind of model, any kind of automated system, could be a neural network that takes in some observation about the world, takes some actions in that environment or that world, which then changes the state of the world or the state of itself in relation to that environment, and gets the next observation and maybe a cookie or a reward at the end of that loop. So you can think of AlphaGo and a lot of other systems that take on this meaning of agent. OpenAI has a definition of agents, which is kind of high level. It's behavioral in nature. So they basically say it's a system that does things intelligently. It intelligently accomplishes tasks, from simple to very complex. Anthropic has yet another lower level, kind of implementation level definition of this, which is agents are basically systems where you have an LLM. So here you're already prescribing some kind of technology. So you have an LLM that directly controls some kind of process. Maybe it's a finite state machine that they're inside of, and they're traversing the states in this finite state machine. Maybe some nodes in that finite state machine have tools, and they use those tools, and they control kind of they determine the control flow of how they traverse this finite state machine. But in the diagram, you can see it's basically a for loop. It's very similar to the RL definition a little bit. So you take actions in the environment, you get some feedback. But on the left and the bottom, you can see there's a new kind of relationship here where you have a human that's interacting with the LLM, and there's some stopping condition where presumably you have completed the task or you have an answer that you're going to give the human. So the point of all of this, just to level set, is I think it's actually fine to have multiple definitions of agents, and these are certainly not the last definitions we will hear in the next coming years. And it's fine to have these at different levels of description, right? The OpenAI one's a lot higher level. It's more behavioral. It's like it's something that performs tasks in a smart way. And then closer to the hinting at implementation details is more closer to the Anthropic definition, which is it's basically a LLM in a for loop with like maybe some reasoning and planning capabilities, access to tools so that it can grab data and do actions in the environment, and maybe some memory, short-term or long-term memory. And I guess that the point of this talk is that to begin to understand what an agent is, one must build one from scratch. And misquoting Carl Sagan here, maybe a joke one can say is that if you want to not bake an agent, make an agent from scratch, you must first self-host the LLM. And this might be intimidating for a lot of people. Maybe, and this statement is actually not true. You can make agents where the LLM is an API call away from Anthropic or Gemini or OpenAI. But really, I think it is, I have a machine learning background, so I'm of the belief that like a lot of practitioners should at least know the concept of backpropagation to really understand how a neural net is trained all the way up the stack to how do you use these things as functions in a software application. So maybe an extreme view, but I think as I'll show you in a little bit, it's okay to make trade-offs around operational overhead of, say, self-hosting your LLM and being productive really quickly to start when you're trying to get a proof of value of agentic application idea that you might have. So this is a little bit tongue-in-cheek. Instead of calling these agents, it is kind of in fashion to prefer referring to these as agentic applications or agentic workflows. And to unpack some of the building blocks here, which is the title of the talk, really, like one way of looking at this is that the agentic system is the middle stuff in the green. So you have some kind of interface to a human. It's a UI or a CLI or something like this that interfaces with an LLM, which is, for all intents and purposes, the core orchestration engine. You can think of it as that calls out, delegates things that it might not know about in its own internal model weights to things like tools or things like external memory, or to log something into an evaluation harness so that the humans maintaining the system can improve it, or maybe it can improve itself, or something like that. And the ... can be any other number of components that we may come up with in the future. Like in a multi-agent system, it could be more agents that it delegates to. And the arrow, don't pay too much attention to the arrow from tools to environment. That's just one way in which LLM can access things in the environment. So really here, obviously the core component, as I just said, is the LLM. And this is the thing that may have reasoning or thinking, quote unquote, capabilities, may have planning capabilities, etc. And I just said all of these points, so I'm just going to kind of breeze through these. So you have tools like API calls, function calls, even in a retrieval augmented generation setting. You have the vector store, so you can think of retrieving stuff from a vector store as a tool as well. You have either short-term or long-term memory, so you could have memory from within a session, interaction with a human. Or you could persist that even longer across sessions so that when you come back next week, it'll know kind of what you asked it and what conversations you had before. And again, as I said, evaluation harness for application builders out there is one of the most critical pieces, because how do you know if your thing is performing well or doing the task that you want it to without actually looking at its performance and assessing it somehow. And all of this together is the agent system. Apologies. And you can think of kind of all these green boxes and all of the arrows as hinting to code that orchestrates all of these subsystems. So for example, parsing responses, correctly routing them to the correct components, coordinating all of the pieces to produce useful outcomes or outputs. So this is something a human or maybe assisted or even an agent can write, other agents, right? So this can get quite meta. But today, given how I would say at the applied research stage, agents are like, yeah, you need humans. you can't automate this entire process of creating agents. So why DIY full stack agents? Well, first, good reason is for fun and learning. It's important to keep learning, especially at this time when things are evolving so quickly. More business-facing reasons might be you work in an organization that wants to preserve data privacy, so you can't send data out to LLM providers, even though maybe they've been building trust and security and things like that. But and this speaks to the third point, which is to unlock agents in regulated industries where just, quick shameless plug to Union, where we serve a lot of companies and organizations who can't make API calls to these LLM providers. They have to host their own LLMs for various regulatory reasons. So just to put this all in context, depending on everyone's background here, you might be a ML engineer or a data scientist or software engineer or something else. I'll call the classical ML world which is, I think there's a track in TMLS this year for this. But this was all about, data processing, model training, model experimentation, and selection. And at the end, you get this model artifact. And then with this model artifact, you do batch or online or streaming serving. And that was pretty much all of ML. I mean, it's a large stack, and you needed a lot of tools for this. But now the tool set has expanded even further with generative AI, where you have patterns like retrieval augmented generation, so RAG. You have agentic pipelines and multimodal pipelines, which further compounds the complexity of these kinds of systems. So high-level overview of what I will hopefully have time to demo very quickly, a kind of a hello world example of agents, is that there's a human, obviously, that interacts. All of this should be kind of familiar at this point, that interacts with a UI or a CLI. And that UI or CLI makes calls to LLM endpoints. So this could be a local OLAMA server, a self-hosted remote endpoint using inference framework like VLLM or SGLang, or like an LLM provider like OpenAI and Anthropic. And so the LLM, that's the LLM piece. The tools part specifically would use something like MCP. I mean, you don't need to use MCP. You could use your own homegrown kind of like API, REST API or something like that, that your LLM can understand as a tool and call. But I think the industry is sort of converging towards MCP as a standard protocol for this. Weights and biases weave is a specific choice for an evaluation harness to be able to log the message stream and the final outputs of any given interaction. You may add eventually agent-to-agent, A2A, the Google framework for multi-agent type stuff, but we'll keep things simple for now. So digging a little bit deeper here, hopefully everyone can read this fairly straightforwardly, but to walk through it, you have a simple agent function call here that we're just calling, can you fix my train model.py script? And then the intended behavior is like it outputs a diff of the changes that it wants to apply to that script. So this is like a bug fixing agent. So first you have the kind of short-term memory, let's call it. So it's like just a message stack that starts with a system prompt and then follows up with the user prompt. And throughout the for loop, again, going back to the Anthropic definitions, just like an agent reduces, you can think of it as like a for loop of an LLM with two calls. So this is literally that in a little bit of kind of a pseudocode, high-level code here in Python. Then you have a MCP client that you assume you have some MCP server somewhere that has all of the tools and resources and whatnot to fulfill the requirements of your application. So this could be a remote or local MCP server. I think I saw answers. I'll kind of follow up with that at the end of the talk. You have a loop, like while the final answer is not defined yet, just keep looping. You basically call the LLM, and if the response from that LLM call is a tool, then you got to parse that response with the tool name, the arguments you want to pass to the tool name. You pass message result to that to the message stack. You then break out of the loop when the final answer is defined. But if it's not the final answer, it could be an intermediary response that isn't a tool call. So it could be just a message that tries to reason through what the planning steps would be that will then downstream lead to additional steps. It might, this is all depending on the system prompt, right? So the system prompt might tell the agent to take vague questions from the user to edit them. So again, this is all kind of hand wavy at this point, but at a high level, these are the 3 steps you would take inside of this for loop. And then finally, you would evaluate and log the messages. So if we were to map this back onto our building blocks, right? So you have an MCP server here. You have some kind of LLM endpoint that you're calling right there. And then you have your evaluation harness over here. Really, during prototyping, you could do without the evaluation harness, but yeah, I think realistically, it's important to build this in earlier rather than sooner rather than later. So shameless plug of Union. This is how you would write a VLLM DeepSeek deployment app. So you request the GPUs you want, you specify the model you want to serve, the resources you want, etc. So this is kind of a declarative model here. Just to show you what this might look like, the MCP server defines some tools. In this case, it's a kind of a simple math, silly math toy example. And then you would then define your Union image and your MCP server here that would be deployed on Union. And then you would create an evaluation harness. So this code on the left here would be in your actual, let's say, CLI application that, let's say, assesses the relevance of the final output against the user query and logs all of it onto the weights and biases platform. And so on the right here, you can kind of see all the logs. So very, very quick demo. Hopefully will take a minute or two. But I have a local MCP client here, and I've configured it to call this MCP server that I'm hosting on Union. This is the Union UI. I'm not going to linger here for too long, but basically this is hosting a server which has been run with this MCP run command. So this is running on a CPU somewhere in the cloud. All I'm going to do is invoke the MCP client. And all this agent, like this Hello World agent does, is it has access to math, the math app that I showed you earlier. So this right here. And let's say add this, oops. And oh man, I can't type this. Then multiply the results by 99. So this will actually start a weights and biases weave session here that will log the results. And let's see if the demo gods will be good to me today. Cool. So what happens first is I'm printing out the tools available through the MCP server. So these are just the JSON function representations of all of these functions here. And then you can see the message log over here where here's a system prompt. You have the original, the user prompt that I just entered here. And then you have basically 2 function calls. You have a function call to add numbers with these arguments. And then you have a function call to multiply the numbers with these arguments, and then it returns the final answer. And just to do a quick sanity check here, so I'm going to do 4, 1, 4, 2, 1, 2. Oh no, I mistyped that. Times 99, and the numbers do match. So just if anyone is skeptical about that. So cool. So that's just whirlwind demo of like a very, very much toy example, but you can imagine that the MCP server can actually do useful things that the LLM doesn't know how to answer. So it could fetch data, it can fetch documentation, it can do all sorts of things that is probably worth a workshop's worth of content to go through. So second last thing I want to share is kind of practical implementation pain points that I have experienced building these sorts of applications out. First is there's a self-hosting LLM operational overhead. I mean, you need GPUs, you incur the cost of that. You need to maybe scale to 0 so you're not over provisioning your GPUs. So there's basically a lot of operational overhead that if you want to self-host your own LLMs that you will have to incur, unless you're doing like a local LLM hosting with Olama or something like that. Another thing I've found is that agents require larger models. So if you're just hand-wavy observation is that if you're using smaller models, things like less than 8 billion parameter models, the LLMs will often get stuck. What I've seen is they won't know what tool to use, or even if they figure out the right tool to use, they'll format the arguments incorrectly. So there's that problem. There's LLM response parsing inconsistencies. So even though the OpenAI client is standard across different serving frameworks, depending on the call patterns, like streaming versus non-streaming, the outputs are kind of inconsistent, which is kind of strange. Maybe it's like a tooling gap type of thing. And relating to this is streaming versus not streaming. Streaming the responses out is obviously better for user experience, and you see the progress of the response more quickly, but it does introduce additional complexity to the code that you write in your agent application. Again, this is why agent frameworks exist, because they abstract all of this complexity away from you. There are, again, I can speak more to the trade-offs there if people are curious. And then there's MCP server security. Up until recently, MCP servers and clients did not support authorization, like secure authorization, but I think that is starting to roll out from what I've seen of late. Practical implementation advice around these pain points is that start with an LLM provider. There's a free tier of Google Gemini, and it's really good. Again, if you're using these LLM providers, like you're using the state-of-the-art models, so the agents requiring large models shouldn't be an issue. Pick one inference framework. I think this is useful because like versions will change, and maybe the output, the IO contract, the API contract can change and kind of like destroy your current break your current logic. So pin the version. Not streaming is simpler, so you might want to start with that. But if you do care about latency and like user experience, go for streaming. And if you do stream and then parse, so stream the output first and then parse that output and then plug that back into the agent loop. And then for MCP server security, if you're hosting locally, it's probably fine. If you're using one that you've built yourself, sure, it's something and if you're using another one that you should at least audit and trust it. I wouldn't pip install like some random untrusted package. So So in summary, you can kind of take a look at these, but basically, it's an exciting time to be building these things. We have good enough local open weights serving capabilities, and even then, all of the LLM providers are quite accessible these days. So hopefully I've given you some of the conceptual and implementation details of how to build these kinds of applications, if you haven't already. And maybe many of you have and have a lot of comments about my presentation. You can reach me by email or LinkedIn. I will be at the TMLS event at the Union booth, booth 6. So come talk to me and the team. I will also be giving a more in-depth workshop on RAG applications, production grade RAG applications on June 18th. So if you're around and interested, come check it out. And the repo that I showed you very briefly is in this QR code right here, which you can try out on Union serverless. And with that, I don't have much time. Let's see if there are any questions I can address.
Yeah, thanks a lot for the great talk. Yeah, I see some questions from the Q&A. The first one, you can also see from there. Can you please guide on framework, like which framework is better for development of agentic AI, especially for production? How to code production ready from starting of the project? What to care for the production ready code?
Yeah, there are a lot of good frameworks out there. So there's obviously like the Langs, so LangChain and LangGraph, and there's also Crew AI, and there's OpenAI's Agentic framework. It really depends on your appetite for coding, I guess. My appetite for coding is a lot, so I like to build things from scratch as much as possible. And obviously, with the Carl Sagan slide, it's like you don't want to train an LLM, so like from scratch is kind of relative to the application. So short answer is I highly recommend people to just use Python or whatever base language they're using, and just like building blocks, just LLM call. So use the OpenAI client or whatever client that just does the raw LLM calls, where you it's a lot more work, but you have to format the messages and you have to parse them oftentimes. But the main reason for me is that because this area is so new, like I don't know what requirements I need actually at the end of the day. And oftentimes with frameworks that I found is, one thing I found with frameworks is they have a clear railroad happy path. And once your requirements fall out of that, you're kind of stuck. And you have to make contributions to that open source code base yourself, which is also cool. So that's also a valid path. But I think to really grok the fundamentals, it's, I think, important to start with these kind of building block primitives. And then once you're used to it and you want to abstract away a lot of things, then yeah, go ahead and use a framework. So that's my approach, but you can certainly do the other way around and start with a framework first, and then kind of customize and write your own code after you fall out of the happy path of the framework.
Yeah, great. Yeah, there's a question. Can you use MCP in production? I guess you covered it in the talk, but do you have something more to say?
Basically, the biggest production issue for me was security. I think a few months ago, they didn't support OAuth or any kind of token-based authorization, but I think a lot of the frameworks out there now do. So in Python, you have fast MCP, which does. And I think clients like Cursor do support passing in security tokens. So I'm sure there are other production considerations there for MCP, but yeah, that would be my answer.
Yeah, another question is, can you elaborate on the semantics of full stack? I think one of the ideas is self-hosted language model inference, but I might be missing something.
Yeah, there are more components, right? So there's the LLM that you may self-host or not. There's the MCP server that you can host locally or on a cloud somewhere. There's the CLI or the UI. So you could use like Streamlit or Grad.io or a bunch of other framework, React, to host the UI. There's coding sandboxes. So if your LLM needs to write code that you don't necessarily trust, you want to send that off into a sandbox that won't destroy your that it can run insecure code basically. So you want to send it off to this code. So there's a lot of components that I haven't talked about, and so I guess in this case the semantics of full stack is basically all the components and how they connect together beyond just the LLM.
Yeah, another question is, I think when we run agentic AI applications, there are many agents working behind. So how cost works or how to manage it?
Yeah, this is a great question. I mean, this is something that's very application dependent, so I can't have a clean, simple answer for this. But yes, people are going ham on agents. Like it's not just one agent; it's like thousands of agents, and excuse me, agents can spin up new agents and all this stuff, right? So this could very much balloon costs, and this is what we found actually talking to customers and some potential people we do research with to understand the market better. Yeah, I mean, I don't have a great answer. It's part of the answer is using easier said than done, but it's using the right sized LLM for the right type of task. How do you even determine that? I don't know. Like, is there a way you can easily evaluate task complexity without yourself using a very expensive LLM to make that determination? So that's one way, is to basically have different tiers of LLMs do different types of tasks depending on the complexity of the thing. But I'm sure there's a lot of other ways people have thought about.
Yeah, let me ask one question. So yeah, your background in healthcare, and these are safety critical issues, and there are also other applications. How do you think the agents are ready for those kind of applications?
Oh man, I mean, in my previous work, I did classical ML in a mental health situation, and even then we were just very conservative about what kinds of models we used. I think LLMs are good for many applications, and Agentic is good, but like my short answer to this is you want to de-risk the worst case scenario as much as possible. And not even explore very catastrophic. If the worst case scenario for a particular application is like death or severe like misdiagnosis and severe ill health, then one de-risking technique is obviously human in the loop. That does add an additional kind of gatekeeping kind of dynamic to the system. So that's just an example of how you would de-risk these kinds of things in contexts like healthcare.
Yeah, there's one more question. Can we build an agent to write an agentic application easily? Any recommended way?
I can't. I cannot recommend any particular way, but yeah, you can certainly try.
Maybe go to your workshop, right?
Yeah, I mean, if you're already using a AI-enabled IDE like Cursor or Windsurf, VS Code, and you're using the agent to build your agent application, then you're already sort of doing it. But to like fully automate that thing, this applies to building any agent application, right? Not just like the meta thing of the agent that builds the agent. But you really want to like conceptually to fully automate this thing, think about what you do as a developer to do this, right? You need access to your IDE. You need the errors that come up as you're coding. You need to write your unit tests. You need to give the agent, the LLM, full context of what's going on here. You need to give it execution access. which hence the code sandboxes I mentioned earlier. So you need a bunch of components to securely even build the flywheel that would conceptually do it. And then, I guess you would just do a bunch of experiments and empirically find out whether it actually does it. I guess, and obviously the first critical component is like the objective, like what is the thing going to do, and what are the unit tests to prove that the thing does what it does.
Okay. Yeah, thank you. Yeah, there are two more questions. Let me say, this one is from your experience in a multi-agent system application. Does most of the calls come from running, generating the answers, or from having to maintain a GPU environment continuously? Also, what's the difference with using local learning model in terms of quality and cost?
Really, this just reduces to the hardware and the running of the hardware. So if you've bought, a bunch of H100s and you've spent that money, the marginal cost is electricity, and so you can just, you can just run them. And if you've loaded a model into memory and they're crunching the numbers and they're consuming electricity, that's like the cost of it. So the nuance is obviously not everyone has the money to do this. They need to use cloud. They need to scale to 0. So like if it's not on demand, they need to provision the nodes. To save costs, you'll have to spin this down to 0 when it's not being used. So there are a lot of like operational things you can do to reduce costs to trade off with latency and cold start and all that stuff. In terms of using stuff locally, in terms of quality and cost, again, it's a hardware issue. Like if I have a M3 laptop, I can run a 70 billion parameter model and like not run anything else on my laptop. And it's pretty good quality. But realistically speaking, if you're doing other things on your computer, then it's like 30 billion or below parameter models, and those do pretty well. I just haven't experimented with these models in the context of an agent too much. So obviously, quality goes down the smaller the model goes.
Yeah, thanks. So next question is, what the job opportunities right now in the industry for agentic AI applications developer, or any?
Union does not have any currently, just as again, shameless plug for the company. We do have, some openings for software, traditional software folks. But yeah, in the broader industry, I definitely see AI engineer pop up a lot more, like on LinkedIn and stuff. So I think I think there's a lot of opportunity. It's sort of, again, this, like, how do you bootstrap from 0? Like, in the sense that agents have been around arguably for, let's see, at most 2-3 years, let's say. So the people with the most experience are the 2-3 years worth of experience, plus whatever other software or ML or data science experience you might have that might transfer over to this. But yeah, there's no better way than to just start playing around with it, finding a use case, a pain point that you have yourself, building something against that, and then getting experience that way. And in job interviews, being able to intelligently talk about what was my goal, how did I do it, what problems did I come across, how did I solve them, what trade-offs did I have to make, those kinds of things.
Yeah, let me ask one more question, probably the last one. Since you have background in reinforcement learning, this year reinforcement learning got the Turing Award. You started from Alberta and Andy from University of Massachusetts. Reinforcement learning is, you also mentioned, it's closely related to agent, especially autonomous optimal ones. So what's your thoughts? Will learning from experience, those kind of things will be helpful? Maybe in the long run, right? What's your thought?
And what kinds of things will be helpful in terms of building agents, or?
Yeah, I mean, any thoughts? It's an open-ended question, I think.
Yeah, I think about this a lot because I have a 1-year-old now, and like I often think of what, not just for him, but for more broadly, everyone else, like what should we be doing? I think if you have too much of a long-term view, you just get paralyzed, because if you've been AGI pilled, then like what's the point of anything? So I don't like taking that view, even though I do acknowledge that it is likely that we have very, very good AI systems in the future. Really, my answer is just learn how to learn. And I like to, I have these kind of cycles of learning and building. So, I'll buy a bunch of books, I'll read those books, and then based on something that I am interested in, based on that reading, I'll try to build something. And then, the rubber meets the road, and all the theory just kind of like, some of it falls apart, and then you have to just go into practical mode and just, really, agents are kind of like a hack, right? Like if LLMs were good enough, they should be able to answer everything, like with the right context. We wouldn't need RAG. You just like put all of knowledge into the context, and it should be able to answer everything, right? So all of this for loops with tools and everything, you can think of as a hack, but really it's like practical, right? Because we don't have that LLM that can answer any question.